Unlike the lust for gold, the exploration of oil wasn't driven by greed, but rather necessity. Oil lamps were the first foray into oil's potential, with origins tracing back tens of thousands of years. Early lamps were simple, often using stone or clay vessels with animal fat or vegetable oil as fuel, and a wick made of natural fibers. These lamps played a significant role in the development of civilizations, from the ancient Egyptians and Greeks to the Romans.
Hey guys, thanks for clicking on this video. My name is Todun, founder of Red City Company, an engineering and construction company. We make videos that educate about people, history, places, and ideas that build the future. Before you continue this video, consider subscribing and turn on post notifications to stay updated.
In the late 1800s, the world made a crucial discovery. Well, not so much the world as it was one man, a man called Edwin Drake. He wasn't a scientist, an engineer, or a prospector. Drake was actually a former railroad conductor who retired early due to illness, but fate nudged him into making history. In 1875, while staying at a hotel in New Haven, Connecticut, Drake met investors from the Pennsylvania Rock Oil Company. They were intrigued by tales of what was called rock oil seeping from the ground in Titusville, Pennsylvania, oil that locals used for medicine. These investors had a bigger dream of using it for lighting. They wanted an alternative to replace the expensive whale oil that was the trend at the time. Drake had no background in geology or engineering. He was chosen to investigate, not because he was an expert, but because he had a free rail pass and a calm, trustworthy demeanor. They gave him the honorary title of Colonel to help him gain respect in town. When he arrived in Titusville, he saw that it was futile to collect oil from the surface seeps. That would be like subsistence farming, which wouldn't match the ambition of the investors. Edwin Drake's first device for drilling oil isn't similar to oil rigs today. It was actually called a Drake well. Drake adapted technology from salt drilling. They began drilling using steam-powered engines to ram a drill bit into the ground repeatedly. After the drill reached bedrock, about 32 feet down, they ran into problems with collapsing walls and water-filled holes. To solve this, they drove cast iron pipes into the ground to stabilize the borehole, which was a key innovation. The wooden engine house would have needed space for the walking beam mechanism, which rocks back and forth to drive the drill. It would also house a steam engine with its boiler and flywheel, and enough vertical clearance to handle the rig's cable system and pipe sections. A modest estimate would put the height of the engine house at around 20 to 25 feet at the peak of the roof. These were often built with gabled roof to allow extra clearance and ventilation. The floor area might have been approximately 12 by 20 feet, just enough space for machinery and a couple of workers to maneuver. On August 27, 1859, at a depth of 69 feet, the drill struck oil. It didn't gush out like we see in Hollywood movie scenes. It seeped up slowly, but that was enough. Enough to prove that oil could be tapped like water from the waterbed. It was enough to change the world. Drake didn't patent his method, so he died in poverty. But his grit lit the fuse of the petroleum age. Others rushed in, copied his techniques, and made fortunes. John D. Rockefeller became the major beneficiary of Edwin Drake's toils. In contrast to a life of unfulfilling grind, the rise of Standard Oil and its founder, John D. Rockefeller, was swift and has remained sustainable till today. The Rockefeller family is still this very day a prominent American dynasty renowned for building one of the world's largest fortunes in the oil industry When the US government broke up Standard Oil in 1911 for violating antitrust laws, Rockefeller didn't lose his wealth, he multiplied it. The breakup created dozens of companies, many of which became giants like ExxonMobil and Chevron. Rockefeller held shares in almost all of them. His fortune ballooned to what will be over $400 billion today, making him the richest man in America at the time. The wealth became generational. The Rockefeller family established trusts, family offices, and philanthropic foundations. They invested in real estate, banking, and education. And here's another segue. We have a really great video coming up about a little bit about Rockefeller family, and more importantly, we want to talk about Andrew Carnegie, who I also find really interesting personally, quite similar to Rockefeller. Anyway, back to the story. Today, the family's net worth is estimated at over $10 billion, spread across more than 200 descendants. Rockefeller turned oil into a legacy. So while Drake gave the world a match, Rockefeller lit the fire, and his descendants are still keeping warm and cozy to this day. The basic process of drilling for crude oil hasn't changed the fundamentals. The technology surrounding it has seen significant advancements. Techniques like 3D and 4D seismic imaging, unconventional extraction methods, robotics, and data analytics have revolutionized various aspects of the oil and gas industry, improving efficiency and reducing costs. Let's go into a little bit of breakdown into what the process for extracting crude oil looks like. You have the first process of drilling, which we've already talked about. And while the basic concept of drilling remains the same, on a deck, hands turning in precise time, driving a string of pipes towards the crude and gas province on the ground. Automation and robotics are playing an increasingly important role. Computer-controlled systems can drill more precisely and efficiently, minimizing human invention and improving safety. Advanced techniques like hydraulic fracturing have unlocked vast reserves of oil and gas that were previously inaccessible. The use of data analytics, artificial intelligence, and digital twins allows companies to monitor operations in real time, optimize production processes, and predict potential issues. Today, crude oil is primarily used to produce energy for transportation. Let's think of gasoline, diesel, jet fuel. It also serves as crucial feedstock for the petrochemical industry, which creates thousands of everyday products, including plastics, solvents, synthetic materials, and chemicals for health and cleaning supplies, as well as fertilizers and pharmaceuticals. It's used in furniture, and then it's also used in electronics. It's used in sporting. You have balls, you have surfboards. They are all oil and petroleum products. So I think, like, if you're listening to this video, the next time you go out, you try to think of or try to spot, if you can, as many petroleum byproducts that you can see. And we're gonna go ahead and link in bio in the comment section. We're gonna link an article to all of the uses of oil in everyday life. So now let's talk about the cost of oil and its impact on the environment. Oil exploration, extraction, and use have numerous detrimental impacts on the Earth's environment and ecosystem. These include air and water pollution, climate change, habitat destruction, and harm to wildlife. Oil and gas operations release harmful pollutants into the environment, including greenhouse gases like carbon dioxide and methane, which all contribute to climate change. These pollutants also contribute to smog formation and respiratory problems. We have an interesting video that talks about air pollution in Pakistan, which is, I think, the second most polluted country in the world, and part of the reason why they experience that much pollution is due to oil extraction activities. One of the reasons, they have a couple of other reasons. One of the reasons: oil spills, leaks, and improper disposal of drilling fluids can contaminate surface and groundwater sources, harming aquatic life and potentially affecting drinking water. Drilling activities, pipeline construction, and oil spills can lead to soil contamination, loss of vegetation, and habitat destruction. The burning of fossil fuels, including oil, releases greenhouse gases into the atmosphere, trapping heat and leading to global warming and its associated consequences like extreme weather events. And when we want to talk about some of the consequences of oil on the environment, we have to look at oil spills. Examples like the Exxon Valdez and Deepwater Horizon disasters highlight the devastating effects of the oil spills on marine ecosystems, coastal habitats, and wildlife. The Niger Delta region in Nigeria has experienced significant environmental degradation due to oil exploration and extraction. Despite the harm that we all now widely acknowledge, the system and society have locked us into an addiction to the flow of oil. The cost of combustion, carbon emissions, pollution, and the spiraling climate crisis can be avoided if we diversify into other forms of energy like hydrogen, wind, and solar. Now, to reference a paper that we've added in this video essay, which is written by Fred B. Olayele, it talks about the geopolitics of oil and gas. Because oil and gas is not only now a climate subject, but it also significantly affects geopolitics. The importance of energy as a major driver of economic activity, and by implication a basic denominator of growth, is well explained by history, especially with regards to how the world's energy use pattern has evolved over the years. Changes in oil prices and availability continue to affect economic growth prospects, international security, and political stability of consuming countries. To a large extent, many contemporary regional energy-driven contentions among producing, transit, and market states determine the world's energy security architecture. While many industrialized economies are working aggressively to develop alternative non-oil based energy sources, their emerging counterparts continue to rely on the relatively cheaper hydrocarbon based energy sources to increase their productive capabilities, at least for the foreseeable future. And when we talk about this, we have to understand that oil plays a significant impact in the world. It plays a significant impact in geopolitics. A lot of countries rely on oil, and I'm sure if you are Nigerian or maybe you're from an oil producing country, you can see the effect of oil, when the oil is selling for higher prices, the country's budget is higher, and when it's lower, it affects the country's budget. I mean, even look at what's happening with the dispute in Russia and Ukraine and how that affected a lot of countries and really destabilized a lot of countries. And even when we spoke about COVID-19, the consumption of oil reduced, and that did affect a lot of countries' economies. According to the International Energy Agency, global demand for energy is expected to rise by 1/3 by 2030 as economies in both developed and emerging countries continue to grow and standards of living improve. The impact of crude oil on the environment far exceed what the layman could even imagine. And in 2015, it was a problem the world could no longer ignore. The UN set up the SDG goals after much pressure to balance some of these impacts. And just as in the oil rush, companies rushed to find oil, New inventors were similarly on the hunt for a cure. One of such companies is Zickens. Zickens is an electrochemical technology company for power generation and hydrogen infrastructure. Established in 2012 in Munich, Germany, Zickens has developed innovative technologies for power generation and key applications in hydrogen separation, purification, and production. Zickens' unique HP platform has been developed in partnership with BASF and offers significantly increased tolerance to gas feed impurities, opening up a wide range of applications in the H2 economy. In 2019, Zickens brought to the market its first fuel cell product, the EcoPort 800, as a replacement for diesel generators. The EcoPort 1500 was launched in 2020. In 2022, Zickens leveraged its experience of commercializing its HT-PEM fuel cells to develop technology for separating high-purity hydrogen from gas blends in gas networks and industrial processes. Zickens currently employs 30 people with a broad range of expertise in the fields of electrical engineering, mechanical engineering, material science, electrochemistry, and energy. We had an amazing opportunity to sit with the CEO of Zickens, Dr. Thomas Klau, to learn more about Zickens' technology, the growth made by its technology, and the impact on the environment. Can you give me a bit of intro into yourself, how you became CEO of Sequence, as well as what your work history has been like? Just give me a little bit of intro about yourself or towards yourself.
Okay. So yeah, I'm an engineer by education.
Great.
I studied in Germany and in the US, in the universities of Karlsruhe, KIT today is called. I studied also at the MIT in
Wow.
Cambridge, Massachusetts. Later on, I obtained my PhD education at the universities of Mannheim and at the Harvard Business School. And then my business career started when I was working for the government back in almost 30 years back, when I was in charge of privatizing the East German economy. You remember about 30 years ago, we had a unification in Germany, and the former communist East German economy was a state-regulated economy.
Yeah.
And I was in the group, in the organization, trust agency, in order to transfer the former state-owned economy into a privatized Western-style economy.
Okay.
From there, I moved on to the aerospace industry, which was Airbus. And then so I stayed in technology for quite some years. Was also working for Infineon, that is the former Siemens semiconductor arm, today an independent company, one of Europe's largest semiconductor companies, where I ran the business for biochips and the venture capital and the M&A activities. And then next step was then I was appointed Chief Financial Officer in the stock-listed biopharmaceutical company called Medicine. Stayed then for quite some years in the medical medtech business and biopharma business before I then moved back to technology, which is now 3 years ago, to Sequence. I joined Sequence actually earlier in the year 2019 as a board member, as a non-executive board member.
Okay.
And then 3 years ago, I was asked to take the helm for the company. So now about 3 years, CEO of the company. The company has a history of about 12 years. founded in, well, actually almost 13 years now, founded in 2012. The company was founded with the task to develop, based on an electrochemical technology, to develop a new sort of fuel cells using methanol as an hydrogen carrier. And it was methanol as a hydrogen carrier because the target market was off-grid power supply in areas also where access is quite difficult. And we'll come to our use cases in a moment. And then in the year 20, it was just when I was coming 3 years ago, we decided to leverage the electrochemical know-how we assumed when we developed the fuel cells, to leverage this technology and this know-how into the hydrogen business, because we saw that a lot of people in the hydrogen business are focusing on production, but very few are focusing on the distribution. And production doesn't make sense when there is no distribution.
Of course.
So what distribution, I think the easiest way for distribution is where it's available, the gas network. It may be a local gas network for town gas, or it may be a natural gas network, because it's easy to blend hydrogen into the gas network, transport it over long distances. But then you need a technology to purely separate and purify the hydrogen at the point of use. So, and this is where we thought this is an interesting market where we don't have too many players in the game. And we developed this, and so now about 2 years later, we had now a couple of very interesting use cases. I'll come also back to this in a moment when we speak about deeper. One of your questions, deeper dive into the technology. I think this is the right way to touch the use cases. So now today we have our 2 businesses. We are globally active and also close to your country. So for example, we signed a contract with some customers in Togo, which is to your country.
Yeah, very close.
So we have customers in the Middle East, MENA. We have customers in the Antarctic. So, for example, there's a French customer where our fuel cells provide power to a French research station in the Antarctic. So I think in the meantime, our technology is now proven. It's we call them the childhood diseases. They're completely debugged, reliable.
Yes.
So very high dispatch reliability. And you can find them from the Arctic Circle in northern Sweden to the Antarctic in the south and once around the globe. It doesn't matter if it's hot, if it's dry, if it's cold, we always make them work. So we have a dedicated power generation solutions team, and they can adjust the ecoports, adjust the fuel cells for certain certain purposes, whatever it is. So, and on the EHS side, electrochemical hydrogen separation, we are getting more and more interest from customers for several applications. So we started in deblending from the gas network hydrogen. Now, in the meantime, we have customers coming to us and say, listen, I have helium, which includes hydrogen, but I don't want the hydrogen, I want just the helium.
Okay.
So we can purify the helium from the hydrogen. Others come and tell us, okay, we have off gases. We know that 40% of the global hydrogen consumption is going into industrial chemical processes. Most of this is going through the roof into the sky, and our technology is well suited to recycle this at high purity, which is why the industry where I used to work for many years is now coming to us, and they intend to use the EHS system to recycle hydrogen out of the off gases of their processes. So, and this is, I think, a very interesting application. I think Namibia is a great country for green hydrogen. And again, Namibia is, there's a lot of sun, there's a lot of wind, because it's
an amazing country.
Centralized, huge, and economic production of hydrogen, green hydrogen. And then in order to transport that, the best way to transport that is if you either use LOHC, liquid organic hydrogen carrier, or methanol or ammonia. I think, we believe that methanol is probably the best one, because the relation of hydrogen to overall weight is the best in methanol. It's about 10%, a little more than 10%. Others are less. So, and I think for methanol, you can rebuild any tanker within 9 to 12 months and refurbish it instead of crude oil shipping ethanol. Then, there's already some ports, Walvis Bay or Lüderitz, there's ports, you may build up the ports and then send the ships with methanol to wherever it's used, Europe, the US, Nigeria, wherever industry needs it. And then as a next step, with our technology, for example, you can then separate the hydrogen in highest purity out of the methanol.
A question I have is that, do some of these companies within the gas network, do they think or do they feel that, you're like a potential competition? Is there any kind of refusal to cooperate, or is it more like complementing them?
Our technology enables the gas network operators to provide hydrogen.
Okay.
We enable the gas network to transport and distribute. Hydrogen. There's an example. I mentioned I was working for the semiconductor industry, so I'm always I like this example. The internet. The internet, we have the backbone for huge data, and then you have the so-called last mile, to distribute into the houses. What we do is we provide the last mile for infrastructure, for the hydrogen infrastructure, make it available in basically, theoretically, every household, every house, every building.
Okay, thank you for that clarification. And I think maybe you can give a little bit more insight into sequence invention and patented technology, but maybe just give a little bit more insight into the tech and how it works today.
I think what is, let's say, this comes to what is our unique selling point at the end.
Okay.
Which is our technology, which is what we have accomplished. If you look into the fuel cell industry, there are several sorts of fuel cells.
Okay.
Most of the fuel cells, they have, let's say, molecular hydrogen, which is a very expensive activity. Some of them are using methanol, but there are different ways of using methanol. For example, most of them are using premixes. premixes, where it means because of that has something to do with the internal management, the membrane, where hydrogen is turned into electricity. The membrane needs to be vaporized, needs to be humid. And so there's for the internal water management, you need the premix of half methanol, half water. Which means, first of all, there are areas in the world where water is very costly.
Yeah.
Then there are others where they need, due to the design, they need a very high quality methanol, kind of almost medical methanol, which is extraordinarily expensive.
Yeah.
So the unique selling point for our systems, and which is why we are now in the Middle East, Saudi Arabia, in the United Arab Emirates, is we are the only guy in town actually where we can use any methanol. It may be industrial grade methanol, it may be of course green methanol, but it doesn't need the purity and it does not need premix. And now we come to our technology. As I mentioned, the systems were designed to work also in areas where access is very difficult, meaning you need a donkey or a helicopter.
Yes.
And in this case, it doesn't make sense to fly with a helicopter 50% water and 50% methanol. Or, so it's just normal methanol, just pure methanol. And this is why our system, this is not just the stack where finally hydrogen is turned into electricity. We have, our system has a certain reformer and other modules in it, which makes sure that the hydrogen does not need to be very purified. The methanol doesn't need to be highly purified. It doesn't need to have premix. We have also an internal certain IP-protected water management process, which allows us to use pure methanol because the internal water management makes sure that the membrane is also without water still humid in order to not collapse. So now the system, how it works is that, for example, the membrane is designed in a way that just the hydrogen molecules are captured. Then hydrogen will lose one of its electrons, becoming a hydrogen proton, and only the protons can travel through the membrane. And on the other side of the membrane, the proton receives back the electron, and here becomes a very purified hydrogen molecule. So that's basically the mechanics behind this membrane. Actually, the membrane and the chemical stuff, there's all kind of stuff, chemical stuff in it. It's a catalyst in it.
Catalyst, everything. Yeah.
It's a catalyst. It's platinum in it. So the chemical stuff is coming from BASF. I'm sure you know the chemical company. They are we are their preferred partner. And actually, on the EHS side, we are their exclusive partner. So no one in the EHS side is allowed to use this technology. I like to call them, these are heavy duty fuel cells, put everything, they will work, which is again interesting for countries where you have no grid in many places, where you can put it in. Same as, for example, we have military usage. So we have now, we are now developing a military version. So many military, many defense organizations here in Europe, because they saw, okay, this may be perfect for to supply power to combat communication, where they're usually off grid, somewhere out in the field. And so far they have combustion engines. Combustion engines are loud.
Yes.
They emit a lot of heat.
Pollution, heat,
Well, let's say in the defense situation, nobody's interested in pollution. But there are two other issues. A lot of heat means it can be easily detected by the enemy with heat detection. Noise detection is the same. And the advantage of our fuel cell is you don't hear them, and they emit very little heat only. Which is why one of the guys from the army said the good thing here is, with the combustion engine, we need to carry them 100 meters away. So if a drone is detecting them, the drone hits it, but not us. The fuel cell can stay next to our truck because nobody can detect it. This brings us a little bit to the use cases. Very often we combine the fuel cells with a solar panel. So solar panel, fuel cell, and a battery. And then the supply, the final supply goes through the battery. The battery is always maintained at a certain level of charges. When there is sun, like here today, or maybe in your country even more often, the solar panel is charging the battery at night, or when there's no sun, which happens here, maybe not so often in your country, then where you have telecom towers but no grid, this is the thing we can use. Same is one thing here, what you have in Germany and also Saudi Arabia is traffic monitoring and control. For example, speed control along the roads, along the highway. There's usually no grid directly, but they have a speed control, and there are our fuel cells.
Oh wow!
If you get a ticket, this has been provided to. This has been powered by Sequence. We sell this. People say. I spoke to a guy. He said to me, because it was in the newspaper. It was in the car magazine here.
Oh wow!
And he said, "I don't like you guys." I said, "No, look it from the different angle. We save lives because the speed limit or the speed control is usually in areas where you have many accidents because it's a curvy street or something like that, and so it helps to save lives and prevents accidents. So see, there is a lot of applications. And we're getting more ideas every day. So one more, the other day I was in Abu Dhabi for a conference. Presented that. And then a guy from Tanzania came, a hotel manager. He said to me, I have a hotel at the Indian Ocean, and the rooms are more single, like little roundabouts as a room. So separate little houses as the rooms, and he said if we can put ecopods in that to provide power to these little houses, which of course is possible.
So I think one of the things I didn't really get was learning a bit more about the sustainable gas network you spoke about. So I don't know if we can talk about that.
So Sequence has two business lines. Both is based on what we call electrochemical technologies. One is the power generation, which is done by our fuel cells. And then the second one is the electrochemical hydrogen separation, which is a technology which literally can separate hydrogen out of many, basically almost all gases. Already I have a lot of interest from the Middle East, where you have also many oil companies. Actually, last Friday, we had a delegation from KSA, which we can, with our technology, let me call it harvest out of process gases, off gases from chemical plants, from refineries and things like that. And so what we also can do, what we have done in a project in Australia, was to separate hydrogen and helium. We need a centralized production for economies of scale and a decentralized distribution for the supply at the point of use. And of course, the best way is to use an existing infrastructure where it is already, and I assume a country with oil and gas, you do have already an infrastructure in place in Nigeria, so that you can use this by blending the hydrogen into the gas network. So this is a German example. You see in Germany, we have the Germany's gas network is 96% hydrogen ready, which means that we just need to blend it in and deblend it. And this is now how it could look like. Here we have a University of Landshut in Lower Bavaria. They are using our technology to produce hydrogen out of biogases. It's a rural area with a lot of farmland. So they have a lot of biomaterials. And out of these biomaterials, they make biogas. And in the biogas, we have about 45 to 50% hydrogen, which we can then, in a highly purified matter array, separate. So, or what you see here is hydrogen recycling. That's what I mentioned. We are here in the semiconductor industry. The off gases of the semiconductor industry, of a chip factory, which is basically close to a chemical plant. There's a lot of process gas with hydrogen, and we can recycle that at a very economically useful conditions. Yeah. So, a couple of demonstrations, for example. This, the left side, this was with Australia, where we showed in January this year that we can separate hydrogen and helium in a very efficient and economic way. So we had super clean hydrogen and super clean helium. Here is now, we assume, a big order to follow soon. And on the right side, you see the blending facility, where from the gas network, the local gas network of natural gas, we could blend hydrogen at in a very pure form as well. That's actually the way how it works. What we developed is the sequence HT-PEM hydrogen solutions. HT stands for high temperature. High temperature is important because low temperature is very sensitive against impurities. And in these gases, usually in the gases, and when there's hydrogen, you always have a lot of impurities. And the high temperature PEM is able to deal with that. So it's very robust against impurities. And it works basically in a way that we separate with the MEA. The MEA is designed in a way that only hydrogen protons can travel through, and on the other side, the proton is getting an electron back, and here becomes a pure hydrogen, and all the rest leaves will not be covered. So this is basically how it works. So it works like we have a special membrane which we developed. The membrane has the ability to bind the hydrogen molecules. And then in the next step, the molecules of hydrogen, they will lose one of their electrons, becoming a proton. Only protons can travel through to the cathode, and at the cathode side, they're getting back an electron. And here, the only thing what you now have is highly purified hydrogen. All the rest on the off-gas side. And here, it's a quick, some economies here. You know, an electrolysis needs between 45 and 50 kilowatt hours for 1 kilogram of hydrogen, plus on top about 10 liters of highly purified water.
Okay.
That's, by the way, one of the challenges in Namibia. They have a lot of green power, but water is an issue because it's in the desert, so it's dry.
Yeah.
And you need for 1 kilo of hydrogen, you need 10 liters highly purified water, plus a lot of electric power. Then you have 1 kilogram of hydrogen, and that contains 33 kilowatt hours, which means you invest about 1.5 times the energy in electric power than you later harvest as energy content in the hydrogen. So it is, electrolysis is a very, very inefficient process.
Yeah, quite wasteful.
Now, if you use our separation technologies, you just need about 3 to 5 kilowatt hours per kilogram of hydrogen. So you harvest 10 times as much as you invest, and you don't need water.
Oh, wow.
So, which means, the reason is simple. What we do is we select and collect the hydrogen, which is basically everywhere in gases, and in off gases, in process gases. Sometimes it comes with natural gases, sometimes it comes even with oil as a gas. So hydrogen is more or less everywhere. And what we do, we collect the existing hydrogen and purify it, whereas electrolysis goes into the molecular structure. So electrolysis destroys the water molecules. And if you get into the molecular structure, you always need a lot of power. So, and since we leave the molecular structure as it is, we just collect what is there, separate it. This is why we need a very small amount of electric power only. Then what is also interesting, we spoke about this with the gentleman from Saudi Arabia, diesel site elimination. In Saudi Arabia, you have in the city of Riyadh, pollution is extraordinarily bad, air pollution, because the electric energy is mostly coming from diesel generations, huge diesel gensets, purely maintained, blowing a lot of dust into the air. And so they are really interested in diesel site elimination by fuel cells. And methanol is a very cheap thing to be made, either green or based on oil, where Nigeria is a lot of. So, and we can use, you can use the methanol then to run the fuel cell, because methanol is a very, very good hydrogen carrier. Actually, methanol is probably the best hydrogen carrier on the globe with regard to the weight, the overall weight of the carrier in relationship to what you get as hydrogen. So, which is why we think that methanol fuel cells is the right thing to go with, using methanol as carrier for hydrogen. Yeah, so this is basically an overview what we are doing. So it's so our solutions are on the power supply side with our fuel cells and the cabinet, which you see here. This is a fully independent power generator with no exhaust gases, no pollution, or here the separation of hydrogen out of, basically spoken, any feed gases, and quite robust against all sorts of impurities.
So I think like one of the second question maybe I had is to kind of figure out like what is Seekin's maybe goals for the next like 5 years, you would say, like what are some goals that the team is currently prioritizing?
Okay, we have our goal is to grow. We are on, let's start with the power generation. On the power generation side, we are currently working on larger fuel cells for more power. This was actually driven by the shipping industry. There is a demand to even replace diesel generators in ships, or diesel engines in ships, by methanol-driven fuel cells. Starting because currently the methanol fuel cells are not in the power range where we have the propulsion system in ships. But what they think is, and this is where we also are currently, we have a customer who asked us to install the fuel cells on the ships as an APU. You know, a ship is, I don't know how familiar you are with a ship, but a ship, I had to learn as well, a ship has the huge propulsion system to drive the propeller, but then they have all kinds of independent APUs, so auxiliary power units, usually as diesel generators, for the propeller to bring the ship sidewise, the side propeller, or for the cranes on the ship. So this is all independent from the propulsion system. And these APUs are used when the ship is in the harbor. And in the harbor, they say, okay, if the ship is out on the sea, pollution is not that much of an issue. But when we have the ship in the harbor, we want it to be more or less pollution free. So, which is why they start with these APU applications. And out of this, we have decided that we will also in the future offer more powerful fuel cells for a lot of applications. The main applications are today in traffic monitoring and control. Then it's critical infrastructure. For example, if the net has a blackout, critical infrastructure, which is police, emergency, needs to be empowered.
Telecommunications.
Then it's for blackout, for example, cool houses in the pharmaceutical industry. In Saudi Arabia, for example, I think this is what I learned last Friday, 90% of the telecom towers in Saudi Arabia have a diesel genset because they are off-grid. So we have some in Germany as well off-grid. But this is the typical applications. Getting into more powerful systems, we can then also go into applications like APUs in ships. One day, probably even the propulsion system. So these are currently the typical applications. And then in the EHS side, hydrogen separation, our goal is to get more and more into recycling of process gases.
Okay.
Because let's say the network, that's what I learned in the last months. I don't see a quick win in the network, which would be a dream, by the way, but it will take time because it's the chicken egg problem. If you invest in the network, you still don't have the users, and the user wait for the network, and vice versa. So probably here will be a trend like based back to base station applications, like, for example, waste trucks or local buses, which come back into the garage at night. They can be refueled, so you only need one hydrogen power station, one hydrogen gas station. This is, you see, and this is the goal for the next 5 years, to really penetrate the market in all off-grid situations with power, and penetrate the market with EHS in making hydrogen available for less than $2 per kilogram. So whereas today's price is between 10 and 15.
Okay, that sounds really great. That sounds great. I think like maybe a question I have, which is a follow-up, is typically what would happen to those gases, maybe for an oil and gas company, when they purify oil or petrol from crude oil? What would typically happen? Is that something they would typically throw away or try to get rid of? Is that considered waste currently? And that's what we're trying to renew into hydrogen gas?
Well, so far what is done in many cases, the hydrogen, which is then, for example, what you can do is if you use helium, you can just burn the hydrogen, because the helium will not be part of the chemical process. Helium is the gas, so it's just burnt. Or in many cases, it's with the off gases and the exhaust gases, the hydrogen include the content of hydrogen is going to the sky, is wasted. So let's say 90% of this is wasted. And by the way, hydrogen as a molecular hydrogen is also as carbon dioxide, a greenhouse gas. But one molecule of hydrogen has the same effect like 30 molecules of carbon dioxide. So actually, that's interesting. Hydrogen has a very positive image, but if hydrogen is sent into the sky, into the air, the greenhouse effect is 30 times as bad per molecule as it is for carbon dioxide.
Oh, wow.
So, it's also good for the climate if we select as much hydrogen as we can. When you burn hydrogen, the outcome is water, which is fine. So, but don't let it go molecular, which is happening right now. Let's say, to answer your questions, frank and short, it's wasted. It's sent to the sky
and wasted. So
it's not only wasted, it's harming.
It's actually a pollutant.
On top of that,
becomes a pollutant. What would you say maybe has been the biggest challenge with market penetration? Because I mean, for me, it's like what it sounds like is that there is more benefits than downsides. So I would say, what has been the biggest challenge with market penetration? Why do you think maybe people have been resistant to that? Do you think it's because it's like cheaper to just burn it, so they don't care?
Market penetration is difficult because so far we have not too many new users. There is almost no hydrogen train. There is only very few hydrogen trucks, and they have a couple of them in China. It's again the chicken egg problem. Why don't people move to the hydrogen truck? The hydrogen truck is good because what uses today 40 liters of diesel for 100 kilometers is about 7 to 10 kilograms of hydrogen only. So it's more efficient, But the infrastructure is not there. So the infrastructure operators say, well, there is no need, there's no customer, so why invest in infrastructure? The potential customer says, well, there's no infrastructure, why invest in a hydrogen truck? So which is why I think, coming back to the 5 years, I think in the next 5 years we should develop the hydrogen industry for the hydrogen user by installing EHS systems where the hydrogen is in the process and needed, which means recycle hydrogen instead of sending it. So I think this is the challenge. The challenge is that we have the chicken egg problem. There is this kind of, is it the user, is it the network? As long as the public investor government says, okay, regardless if it's needed or not now, we just build it for a couple of billions.
Yes.
If it's there, users will come.
Yes. Yeah, it's just exactly like with EVs. You know, as electric vehicles are becoming more and more like popular, you know, you have the electric swapping stations and charging infrastructure also growing steam. So that makes sense.
Right.
So I think like till today, how much energy would you say Zikins has generated? And maybe do you guys have an idea on how much pollution that the company has like cut to date?
So yeah, here this is here you see so this is typical applications, off-grid applications in Norway, Germany, Austria, usually telecom towers for the critical infrastructure, or here are construction sites. And here, for example, we have the what you were asking for, some numbers probably. If you compare the diesel generator and the EcoPort 800 as a cabinet, you have a consumption per day of about 45 liters of diesel, emitting carbon dioxide of 118 kilograms. If you have the EcoPort as we sell it, it's a consumption of 5.5 liters methanol compared to 45 diesel, which emits 5.89 kilogram of carbon dioxide based on industrial methanol, pure industrial methanol. If it's green methanol, it's zero. But you see, even if you have normal, cheap industrial methanol, it's about 5% of what is emitted here. And the nitrogen oxides, which is seen to be toxic, is a kilogram versus nothing here.
Wow.
So that is, and you see, this is the cost based on Germany. In Germany, a liter of diesel is about 1.50, €1.50, €1.40. Then methanol is about 50 cents, maybe 60. Green methanol is 70 cents. So you have in Germany, you have a savings of about 85% of cost savings, plus you have no maintenance because it's an electrochemical process. Nothing turns, nothing needs to be lubricated. There is no change of oil.
Mechanical.
No mechanical moving parts.
Okay.
Or here, this is why we think methanol is the right carrier for hydrogen. If you have molecular hydrogen in these gas tubes, you see a package of, they typically come in packages of 50 liters, which means the total weight is 1.4 tons. If you use methanol, 1,000 liter weighs 850 kilograms. It contains 99 kilograms. So by a little bit more than half of the overall weight, you have about 7-8 times as much hydrogen at zero pressure. And of course, this is the molecular hydrogen can directly go through the fuel cell. If you use methanol, you need our system, which is a system which is generating the hydrogen out of the methanol, which is then going to the fuel cell, to the stack. Is cheap wherever you have oil, you have cheap methanol, which is the case in KSA. It should be the case in Nigeria. And methanol is a really good carrier for hydrogen because the weight is low. Second, it's not a big pollutant, so if you spill it over, it's not like diesel or like petrol. You may use methanol in naturally protected areas because it's harmless, and you can transport it in just a plastic container, which makes it very suitable for many off-grid situations. So where you have only access with helicopter, they have our fuel cells for border control, border monitoring, things like that. Most suppliers need a premix of half water, half methanol, which means you carry around 50% of water, which is also good. In our case, you can have pure methanol, because we have another trick internally in our process, dealing with the methanol in a way that beside the hydrogen there is some water generated out of the methanol as well, so that this moistures the mare. So and on top, efficiency of our fuel cell is probably the best worldwide.
Yes, that sounds really great. The fuel that the generator runs on, does it specifically have to be from Zickens, or can it be any kind of hydrogen? It will run just as well.
Thank you, Tutu, for asking that, because that's one of our unique selling points. Our competitors, they usually have predefined pre-mixes or special special purified methanol. So you have to sell it from them. We are one of the very few, probably the only supplier of methanol fuel cells where you can put any industrial grade methanol, which is not very purified, it's industrial grade methanol, regardless from whom. We are happy. We also offer industrial grade methanol from Sequence, but you can use any methanol from wherever you get it.
That's amazing. The next question we would want to segue to is maybe like, what are some projects that you can speak on that are specifically using Zickens technology?
For example, we have huts, tiny houses, for example, which are powered by, they're sitting in somewhere in an off-grid area. They are powered by an EcoPod. We have little boats, houseboats are powered by EcoPods, even for the propulsion. That is, there's enough power.
I know, like, this is the future of cities, somewhere, a country like Saudi Arabia is already aware of that. That's part of why they are doing all the investment into the green space, is that they know that there's going to come a time where we are going to have to make different decisions, in as much as everyone is trying to push that timeline back. But it just keeps on looming in the background. Like, there's no getting out of it, So, that's part of why I make all these videos, to kind of like enlighten people that, it doesn't have to be a big change. It can just be one tiny change that you make, but it will help a lot. It goes a long way. I mean, you even educating me on how much pollution is even caused by just purifying these gases is revelatory to me. So
Red City.
Yes. So we do construction, we employ sustainable engineering practices with our construction. All right, thank you so much for your time. Really appreciate you getting back on here with me.
Thank you very much.
All right, thank you. Have a good day.
Thank you.
Bye.
Bye-bye.
And while the world's addiction to oil can't be completely quelled, perhaps Our appetite has grown too big. Perhaps oil is far too important now in our modern world. But we can, of course, keep engineering new alternatives. And it's great that we have technological companies like Zircons providing new, cleaner options to advances in energy production. Thank you guys so much for watching this video. If you liked it, please don't forget to like, comment, subscribe. I think this is a video or a story I'm really personally passionate about, because you know, energy is how the whole world operates. And this video is not to say that oil is bad, because there's just quite a lot of things that oil makes more accessible. It is the cheapest form of energy to this very day. I'm gonna leave all the things in the outro, so do your thing, guys. Thank you guys. Bye.
If you want to support us making videos like this, check out the links and support the channel. If you like this video, like, comment, subscribe, and let's get to our next landmark. Not sure what that will be yet, but thank you for watching.